And the questions were, what were the skills that the sector needed going forwards? How does the sort of changing context of the industry, we've had a few developments in Wales, different firms opening, closing, so how does that changing industry context inform the need for training and education? What training is there within the sector at the moment? So what are people doing at the moment? And then identifying those gaps where there's a need for additional training. And you'll see this format's quite familiar. My colleague Gareth at the back did very similar for the marine energy sector, so you sort of know the score here. And we're looking from a perspective of engaged scholarship. And Van der Ven, he says about the idea of research for industry and with industry, not sort of looking at it as a distant observer, but actually engaged with professionals. And I think this is a really interesting perspective for people that are looking to conduct similar analysis. So the Industrial Advisory Group was a group of companies throughout Wales in different sectors that got together around the table to say, what are the needs of the industry, where do you feel the gaps are, what does your firm need? And we've held a number of different events, and some of these have also gone into informing the UK solar photovoltaic strategy by the Department of Energy and Climate Change. And this is a high-level document produced by government saying, what's the ambition for the United Kingdom in terms of solar energy moving forwards? And this is something that our Professor Stuart Irvine has been very active in feeding into. So, industrial context. Sharp, the big Japanese manufacturer of electronic goods, you might have seen their televisions, microwaves and stuff like that. They had a factory in Wrexham which produced solar photovoltaic panels. And unfortunately, earlier this year, the factory closed. And this was quite a bad thing for the sector, you know, a real loss of confidence, because obviously it was a lot of jobs to begin with, but also Sharp was seen as being very significant as a sort of anchor business for the sector in Wales. And there's lots of smaller SME firms that are trying to develop new technologies, but no one really on the scale of Sharp. And so there's a bit of a concern here, because once an industry starts to lose critical mass, what do we do? You know, how do we compete? How do we make sure that the industry in Wales is effective? Especially with lots of other new entrants. Just how can we explain the closure of Sharp? Well, Sharp manufactured a certain technology called crystalline silicon. And this occupies the bulk of the marketplace at the moment. These are the solar cells that you're most used to seeing. And the local MP, Member of Parliament, as sort of government official, said that it was changes to the funding structure for photovoltaics and changes to how people could invest, because we have a new government in the UK and they sort of started to change things about. And he said that like the new government that's come in is to the right of the previous government, and there's been a lot of people in government that have been against renewable energy technologies and haven't necessarily said the most supportive things. And he felt that this has created a climate in which renewable energy firms weren't thriving. However, there's a bit more to the story than that, because we've got to situate Wales in an international context. And this graph here shows the exports and the markets that factory in Wrexham was serving. And as you can see, between 2010 and 2013, the actual panels that were being shipped to Europe have decreased significantly. Sharp never really sold much to the rest of the world, but the main market that this factory in Wrexham in Wales was serving was in fact Japan. And there's some real madness here, because what was happening was that the modules, which are the individual components of these arrays, were being shipped all the way over from Thailand to Wales, assembled into modules there, which is a relatively low-skilled job. There's not a lot to it, sort of laying them on a sheet, soldering them together and encapsulating them, and then they were being shipped back to Japan. So you don't need to be the world's best businessman to see that this was absolute madness. And how could Wales compete in this sort of landscape? Well, Professor Stuart Irvine, this is a chap who's director of the Centre for Solar Energy Research, has said that we need to concentrate on high value manufacture. So not just sort of assembly of things, but actually looking at sort of novel processes, things where there's real knowledge, real value added, because obviously we're competing against low cost countries. And so if you look at Wales, there's actually an awful lot of strength within the country. There's a lot of academic research going on at different universities, and there's also specialist companies that are producing a range of different exciting and innovative technologies. So whilst crystalline silicon cells occupy the bulk of the marketplace, there's actually new types of solar cells, thin film solar cells, which are potentially cheaper, not quite as efficient, but they compete on the cost for the amount of power that they produce. And also dye-sensitised solar cells, which is another new, novel type of solar cell. Now, because these only occupy quite a small market share at the moment, because they're a technology that's in their infancy, there's not a lot of information about them. So this was identified as a gap for the skills. And so yeah, good comparison between these new types of cells and the crystalline silicon cells that Sharp were producing. They compete on the basis that they're less efficient, you need a bigger area of them to produce the same amount of power, but they're lower cost, and that's the absolute key to trying to get these technologies into the supply chain. But there's also another thing. In Wales, I don't know if anyone's ever been there, or if you've seen the NATO conference on the news, we're not blessed with the best amount of sun in the world. We've often got clouds, overcast skies, and one of the things about thin film cells is that they're really good at capturing diffuse light. Okay, so light that's bounced off the clouds rather than direct sunlight. So actually, if we move to these different technologies, it could be quite a good fit with the region in which we're hoping to deploy them. One of the problems is as well is that within industry, if you look at the people that specify solar cells, thin film cells aren't seen as a default option. They're seen as sort of a substitute product. So how do you persuade people to change from their regular brand to a new, different type of product? And that's quite a challenge. And this is another thing where we've identified the need that actually education and educating people that will specify and install solar panels about these different technologies and that they are out there and there's the potential they use. And also, if we're looking at sort of the competitiveness and the argument for doing this, one of the things is that these thin film cells are exactly what they say on the tin. They're a very thin coating of chemicals on a piece of glass or whatever, rather than a thick piece of specialised silicon. And that's good because it means that the materials costs are a lot lower. So we've got the labour costs and we've got the materials costs. And this is another thing where we think that Wales can compete with thin film cells. Now, one of the other problems is, and another reason for education, is that because silicon cells are so commonplace, the machinery to produce them is really well understood, and so it's almost like a commodity. If you want to buy a plant for fabricating silicon, there's any number of people that will supply it to you. Whereas because thin film cells only occupy a smaller percentage of the marketplace, because they're quite new, a lot of the technologies are proprietary. So again, there's this need for education across the supply chain. Now, in addition, it's not just about the solar panels that you see on the building, it's also about all of the electro-technical equipment that supports that cell and connects it to the grid. So you've got the solar panel on the roof, you've got cables coming down from the roof, and you've got switches and isolators, and a device called an inverter that takes the high current DC and converts it to low current but high voltage AC, which is the plug that you find on the wall. So there's an opportunity for the whole supply chain here, people that make cables, switches, fuses, breakers, to engage with this. There's a need to educate these people that are already in Wales at the moment producing cables and switchgear about the opportunities that are afforded by different photovoltaic technologies. So, looking at the training that was out there in Wales, we found 10 postgraduate courses, 3 of which had solar-specific content. But the thing that really surprised us was that people were only introducing solar PV as part of a much wider degree about energy technologies or renewable energy. There was actually a dedicated degree that focused on solar photovoltaic technologies at postgraduate level. And this is something that we thought at Glyndwr University, there's an opportunity in the marketplace here to develop a master's course in photovoltaic technology. In Wales, there's a place called the Centre for Alternative Technology. I'm actually a trustee of CAT, it's well worth a Google, www.cat.org.uk. And that's a centre that specialises in renewables and sustainability. And they offer a 6-day course. And at the moment, that was the sort of most dedicated offering in the marketplace on solar photovoltaics. So, framing the sort of need for new research, we've seen that the closure of Sharp was a big blow to the industry, certainly in terms of confidence. And there's also concern about some other firms that have got technologies that are based on crystalline silicon, because it's very hard to compete with those low labour cost countries like China, Taiwan and the Far East. But there's also some specialists, there's also some different people out there in the marketplace that are producing these novel technologies, thin film, dye sensitised, and this company IQE that produces silicon solar cells, but they're very, very specialised. They're what's called multi-junction cells, which are where you've got large concentrator, either a lens or a mirror, that shines the light onto a very small area. And I think that they're probably quite safe because that technology is still quite complicated and something that requires specialist knowledge to fabricate. But, so as we've seen, although there's these risks and dangers, there's also opportunities, possibility for a vibrant potential for growth, and a need to sort of really encourage diversity within the industry in order to make it resilient and able to withstand these different technology shocks. Another opportunity that we identified was that there was European legislation coming along about the end of life of photovoltaic devices. So we've had that called end of life legislation for a lot of other electronic goods. It means now that if you buy a television or a car in the European Union, the person that made that TV or car has got a responsibility to take it back at the end of the life, recycle it, design it for disassembly and stuff like that. Or they can pay a fee to sort of offset that obligation. And so this was now extended for photovoltaic technologies. And that presented a challenge because obviously there was the infrastructures in place to take photovoltaics and recycle them. And so we saw that people within the supply chain weren't aware of this legislation and there was a need to address that gap. So we planned 3 courses, one in those end-of-life considerations, so educating people about the legislation really, but also system design considerations and building integrated photovoltaics. So again, simple bread and butter courses for installers looking at how these technologies could go into buildings, but focusing on those different options, thin film, dye sensitised, concentrated solar cells, trying to get people to think creatively that it's not just about cheap silicon that you can put on the roof, but there's also other technologies out there. There's a list of references. Thank you for your attention.